Special equipment in the drill string includes drilling jars, measurement while drilling or MWD tools, and mud motors. The rig crew installs a drilling jar in the drill string if there is a concern of becoming stuck. Drilling jars are usually made up in the upper part of the bottom hole assembly, with drill collars placed above and below the jars. When activated, a drilling jar provides a heavy blow to the stuck portion of the drill string below the jar. Often, the blow delivered by the jar is enough to knock loose the stuck string. To create a jarring blow up with a hydraulic jar, the driller lowers the drill string to cock the jar. Then, the driller applies an upward pull. The upward pull puts the up jar in tension and allows the jar trip mechanism to slowly bleed. Eventually, the jar trips when the hydraulic oil bleeds past the ports. The drill string contracts, rapidly accelerating the bottom hole assembly above the jars. When it reaches full stroke, the jar mechanism suddenly stops the motion energy of the string. When the motion suddenly stops, it converts the kinetic energy, or energy in motion, into impact force on the stuck point. This heavy upward blow may free the stuck string below the jar. Measurement while drilling, MWD tools are a big help to the driller as the bit drills. Crew members usually place the tool in a special drill collar close to the bit. MWD tools sense downhole conditions and transmit them to the surface. There, the driller monitors the conditions in real time. Most MWD tools create pulses in the drilling mud. These pulses carry the downhole information up the drill string to the surface. Information collected by an MWD tool includes rock properties, the direction the bit is drilling, torque, and weight on bit. Often, when drilling a directional or horizontal well, a mud motor is made up in the bottom of the drill string, just above the bit, as shown here. It's called a mud motor because drilling mud rotates the bit. That is, when using a mud motor, only the bit rotates, not the rest of the drill string. Mud pumped down the drill string enters the top of the mud motor. When pressurized drilling fluid is forced between the elastic stator and the eccentric steel rotor, a torque is applied which causes the rotor to rotate. The rotor is connected to a drive shaft, which is connected to the bit. Note that all the drill string does not rotate. Sometimes a well is drilled at an angle. This is called a directional well. The well is steered at an angle specified in the drilling program for many different reasons. For example, they may drill directionally sometimes if the oil or gas reservoir does not lie directly under the rig site. Horizontal wells are drilled for many different reasons. Certain reservoirs can be produced better if a horizontal portion of the well passes through the formation. The transition to the horizontal segment of the well begins at some point in the vertical portion of the well bore, as shown here. This point is termed the kickoff point. The horizontal segment of the well can extend for several thousand feet. Specialized drilling equipment and techniques are required to drill horizontal wells.